Hello, welcome once again to Chem is Try. In this video, we'll be talking about chemical equations. Chemical reactions are represented by chemical equations. Imagine somebody telling you to write iron reacts with sulfur to form iron 2 sulfide. Instead of writing this whole sentence, there's a simpler way of writing it. And that simpler way of representing it is what we call chemical equation. For instance, we have this as a chemical equation. Let's look at the chemical equation carefully and try and understand the components of the equation. First, we read this reaction as 2 moles of hydrogen gas combines with 1 mole of oxygen gas to produce or to form 2 moles of water in the liquid state. So clearly, you can see that these alphabets written in small letters inside a bracket constitute what we call the state of the substance. So the state of H2 over here is a gas. The state of O2 is gas. The state of H2O is liquid. Now, when you want to write for solid, you just write small letter S. There's another one called aqueous, which means that substance has been placed in water. And that one will be written as AQ, also in bracket. Okay. These are called coefficients. The numbers in front of the symbols of the substances. We call them coefficients. So you can see that H2 has a coefficient of 2. O2, there's no number here. But in math, we learned that if you have 1x, we can simply write it as x. So if there is no number in front of the symbol, it means the number over there is actually 1, but we don't write the 1. Then over here too, we have 2 as the coefficient. You can see that the whole equation can be divided into 2 portions. The right-hand side and the left-hand side. The left-hand side and the right-hand side are separated by an arrow. This arrow. Now, this arrow means to produce or to form. If you come to the left side, all the substances to the left of this arrow constitute what we call reactants. We can also call them reagents. They are the raw materials that we are going to bring together to form something. And that something we are going to form is at the right-hand side of the arrow. That one is called the products. So we have reactants combining to form products. These coefficients can also be called moles. These coefficients can also be called moles. That is why we read this reaction as 2 moles of hydrogen gas combining with 1 mole of oxygen gas. Now this plus at the reactant side means combines with, which means if we have 2 or more substances at the reactant side, they are going to be separated by plus, telling us that we are combining those things. And when we combine them, we are going to form products or products. This is the general overview of a chemical equation. This arrow can come in another form. The arrow could be written as this or that. When the arrow is written like this, it means that the reactants, which are always at the left side, and the products are at the right side. It means that the reactants combine to form products, and the product also break down to form back reactants. So it looks like a double arrow, each one pointing opposite directions. And it is reactions like these are called reversible reactions. We might talk about them in later videos. But remember, you could either see one arrow or this kind of arrow. And when you see this arrow, it tells you something different from this one. This one means the reaction is going into completion. All the reactants are combining to form products. Simple. But when you get it this way, it means as the reactants combine to form products, the product break down to form back the reactants. And they are special kind of equations. We are going to talk about them later on. Chemical equations obey a law. That law is called the law of conservation of mass. It is also called the law of conservation of matter. This law was proposed by Antoine Lavoisier, and it says that matter or atoms can neither be created nor destroyed in a chemical reaction. We've all heard that law before. What that law means is that if we start with 2 hydrogen atoms, we are supposed to end with 2 hydrogen atoms. If we end with 1 hydrogen atom, it is telling us that one of the hydrogen atoms has been destroyed. The law has not been obeyed. If you start with 4 hydrogen atoms and you end up with 6 hydrogen atoms at the product side, it's telling you something, that you have created additional 2 hydrogen atoms. The law has been disobeyed. To balance chemical reactions, make sure the number of atoms at the reactant side is equal to the number of atoms at the product side. That is what makes an equation balanced. In the latter parts of this very video, we are going to learn how to balance chemical equations. But before we get there, let's talk about the types of chemical reactions we have. So that when we are given certain reactants and we are asked to provide the products, we'll be able to predict accurately what the products are going to be. Now, we are going to consider about 5 types of chemical reactions. The first one is what we call synthesis reaction. The word synthesis means to manufacture or to make something. So, synthesis reaction normally involves the formation of a product. But to form that product, you will need to combine 2 or more reactants together. An example is the first equation we used. We want to form one thing, which is water. And we formed that water, which is one thing, by combining 2 separate things, hydrogen gas and oxygen gas. Now, that is what we call a synthesis reaction. So normally, we represent it this way. A plus B to produce C. So I can give you an equation. Fe plus oxygen gas. Then I ask you to predict what we are going to form. You see, we have 2 reactants. coming together. It's a classical example of a synthesis reaction. So we are supposed to form a product. And that product is formed by directly combining these two reactants chemically together. You can see the same over here. Hydrogen, oxygen. Combine them directly. H2O. Water. These kind of reactions are what we call the synthesis reaction. The second one is what we call decomposition. Decomposition reactions. It's the reverse of the synthesis reaction. Over here we have one reactant, but we are breaking it down into its individual components, which are now going to become our product. So it is normally written in the form AB, which is the combination of A and B, breaking down to form A and B. So you realize the decomposition reaction is the reverse of the synthesis reaction. An example is when we have water. Then we decide to break the water into its components. And the components of water are hydrogen gas and oxygen gas. Now that is a decomposition reaction. So always remember, for synthesis, two or more substances coming together to form one substance. Decomposition, one substance breaking down to form two or more substances. I've not really balanced these equations. I don't want to talk about balancing chemical equations now. That's why I'm not balancing them. I'm leaving them unbalanced for now. When we talk about how to balance chemical equations, we are going to come back and balance these equations. The third type of reaction we talk about is combustion. Combustion. We all have heard combustion before. And when we talk about combustion, what we mean is burning. And to burn something, there's a chemical substance that needs to be present, and that is oxygen gas. So reacting a substance with oxygen gas is called combustion. For the sake of these types of reactions we are talking about, I am going to focus on compounds that contain carbon, hydrogen, and sometimes oxygen. Those are the ones I'm going to talk about. So if you have a compound containing carbon, hydrogen, then probably oxygen, then we react it with oxygen gas. What we are saying is we are burning the compound. And when we burn that compound, we should know what we are going to form. Any compound containing carbon, hydrogen alone, or carbon, hydrogen, and oxygen, whenever you burn that compound in oxygen gas, you are going to produce carbon dioxide and water. Simple. So, for instance, if you have C2H4, this compound contains carbon and hydrogen only. When we ask you to burn it, they don't necessarily need to tell you what we are going to form as product. You should know that this is containing carbon and hydrogen. And since we are burning it, we are going to produce carbon dioxide and water. Once again, I'm not balancing it. Imagine you have C6H12O6. That is glucose. It is made up of carbon, hydrogen, and oxygen. When we burn it, what are we going to form? Carbon dioxide and water. Please, the burning I'm talking about here today is complete burning, complete combustion. That means we have more oxygen around to keep these compounds burning. However, if the oxygen gas is limited, it's not that much, we don't get a complete burning. We don't get a complete combustion. And incomplete combustion do not produce carbon dioxide and water. No, they produce carbon monoxide and water. So this one happens when we have complete combustion or complete burning. If the burning or the combustion is incomplete, then things are going to change. C2H4 in incomplete combustion is going to produce carbon monoxide and water. Glucose undergoes incomplete combustion to produce carbon monoxide and water. So over here, all you need to hear is either the burning is complete or incomplete. If complete, we are producing carbon dioxide and water. If incomplete, we are producing carbon monoxide and water. The fourth reaction we talk about is the single replacement. Single replacement. As the name suggests, you are going to replace using a single substance. And the replacement is going to be only once. So it is normally written in this form. Supposing you have X facing A and B combined together. AB. What happens? X takes the position of A so that we will form XB. Then A stands alone. Single replacement. It is also called single displacement. Two names. Either single replacement or single displacement. And remember, for X to be able to replace A, X should be more reactive than A. A sterling example is the reaction between zinc metal and hydrochloric acid. We realize hydrogen was working with chlorine. Zinc was standing there alone. But since zinc is quite stronger than hydrogen, it will replace the hydrogen so that the hydrogen will now stand there alone. That is what happens when you have a girlfriend and both of you are working. Then you meet a rich man. What happens? The rich man comes to take your girlfriend and you become lonely. That's it. The fifth type of reaction we'll talk about is the double replacement. Just like the single replacement, there is a replacement. But this time, it is what we call swapping. Swapping. So imagine we have X working with Y. Then A working with B. X is a cation, Y is an anion. X is a cation, A is a cation, B is an anion. So what happens? This cation pairs with the other anion. Then this anion pairs with this cation. So that we will form XB and AY. This is what we call double replacement reaction. It's a swap. So an example is when you have NaCl meeting up with PbNO3, cation, anion, cation, anion. What happens? Swapping. This cation will pick this anion, then this cation will pick that anion. So that we are going to form sodium nitrate Then lead to chloride. Swapping. All these equations are not yet balanced. I want to reserve it for when we talk about how to balance chemical equations. Then we will come back and use these ones as our assignments and come and balance them on our own.